Most people think breakthroughs are sudden. We see a result, assume the origin, and perhaps even attempt to construct a story where the breakthrough or even miracle arrives fully formed, as if divinely bestowed, like it has no prior history. No, there's a number that governs how things actually grow, how they evolve over time. And it has been operating in our lives, whether we've acknowledged it or not, whether we were ever ready for it or not. The number in question, the one running beneath every breakthrough ever recorded, is E. At age 4 or 5, ill and lying in bed, Einstein's father gives him a compass. In his autobiographical notes, Einstein writes, "A wonder of such nature I experienced as a child of 4 or 5 years, when my father showed me a compass. That this needle behaved in such a determined way did not at all fit into the nature of events which could find a place in the unconscious world of concepts. I can still remember, or at least I believe I can remember, that this experience made a deep and lasting impression upon me. Something deeply hidden had to be behind things." He spent the rest of his life chasing that disturbance. What invisible force moves the needle? That question is the earliest data point we have. The compounding had already begun, 20 years before anyone was watching. Einstein is 23 years old. He has spent 5 years stateless, having renounced his German citizenship in January of 1896 at the age of 16, stepping deliberately out of a country whose militarism he wanted no part of. At the age of 17, he enrolled in the mathematics and physics teaching program at the Swiss Federal Polytechnic Institute, graduating in 1900. He existed in bureaucratic limbo until February 21st, 1901, when Swiss citizenship finally came through from the canton of Zurich. That year, he scraped together what he could: temporary teaching positions, letters to professors across Europe asking for academic appointments, every one of them left ignored. In March of 1901, his first scientific paper, Conclusions Drawn from the Phenomena of Capillarity, is published in Annalen der Physik. In the summer, he works as a substitute teacher at the Technical School of Winterthur. In the fall, a tutoring position arrives through a teacher of mathematics, Dr. Jane Nusch in Schaffhausen, preparing a 19-year-old Englishman for the university entrance exams. September 1901. Einstein writes to his former school friend, Marcel Grossman, "However, I am now also in the happy position of having gotten rid of the perpetual worry about my livelihood for at least 1 year. That's to say that as of September 15th, I will be employed as a private tutor by a teacher of mathematics, the so-called Dr. Jane Nusch. You can imagine how happy I am, even though such a position is not ideal for an independent nature. Still, I believe that it will leave me some time for my favorite studies, so that at least I shall not become rusty." It lasted 4.5 months instead of the year he had hoped for. Disputes with Nusch, no money, a pregnant girlfriend 20 kilometers away in Steiner am Rhein that he could barely afford to visit. Mileva Maric, the only woman in his physics program at ETH, the one who picked his ideas apart and handed them back even better, had traveled to be near him and was staying at the Hotel Steinerhof, waiting. Mileva wrote on November 13, 1901, "So now you are again not coming tomorrow, and you don't even say I'm coming on Sunday instead. But you'll surprise me then, for sure, won't you? But you really don't have any money left?" In a response letter to Mileva on December 12th, Einstein writes, "I therefore decided to set myself up here as comfortably as possible. I therefore went to Nusch and I told him to give me the money for the meals, so that eventually I might save a little money. He said, aflush with rage, that he has to think about it. Then he conferred with his fine little spouse. When I returned in the evening, he was very snotty and told me with an authoritative expression, 'You know our conditions and there's no reason to deviate from them. You can be quite satisfied with the treatment you're getting.' And I said, 'Very well, as you like. I have to give in for the time being. I'll know how to find living conditions that suit me better.' Imagine what nerve, in my position." He understood that and he softened up immediately. He noticed that I am less concerned with saving money than with not wanting to eat with him and his fine family, swallowed his rage and told me as softly as he could, 'Would you be satisfied if I arranged your meals somewhere in a restaurant?' I immediately understood why he did that, so that it shouldn't be possible to calculate how much he steals from the 4,000 francs put out for me. So I happily agreed and took my leave, remarking that he should make the arrangements as quickly as possible. I had attained my goal after all. They are now foaming at their mouths with rage against me, but I am now as free as the next man. Long live impudence, is my guardian angel in this world. Shortly after, he moved into a room above a restaurant where he lived until the Schaffhausen position ended entirely in January of the following year. It was through Marcel Grossman, the same friend he had written to just months earlier, relieved simply to have work, that Einstein learned of the opening at the Swiss Patent Office in Bern. On December 18th of 1901, he submitted his application, a position he would never have reached through the formal channels that had already closed every door to him. Even Einstein needed a connection to get his foot in the door. The most consequential mind of the 20th century did not get discovered by some system looking to recognize genius. He got through because a friend believed in him when no institution would. That is also E. Signal traveling through a connection, a relationship, before it ever reaches formal structure. Around the same period, Einstein submitted his doctoral dissertation at the University of Zurich and withdrew it in February of 1902. The same month, Mileva gave birth to their daughter Liserl in Serbia. The exact reasons for the withdrawal remain unclear, but the timing was not insignificant. He arrives in Bern in February 1902 and waits. No position yet, no certainty, just the application already submitted and whatever work he could find in the meantime. In June 1902, the Patent Office offers Einstein a provisional appointment as a technical expert third class. He starts working 4 days later along with 12 other experts at the lowest salary level, 3,500 francs a year. Then, October 1902, his father dies in Milan. Hermann Einstein had been the one to hand him the compass, the one who opened the first door, gone before the work that compass set in motion would reveal itself to the world. Einstein called the Patent Office the worldly cloister where he hatched his most beautiful ideas. He wasn't merely a clerk. He was a technical expert assessing the viability and originality of inventions, parsing how things work, checking technical drawings, stress testing every claim. The known approach was to evaluate each patent as if everything the inventor claimed was wrong, to push against the inventor's framing and independently assess the technical merits of what was actually being described. By day, mechanical patent applications. By night, the nature of light, time, and space. Einstein would later write, "The conventions at the Patent Office have driven my standards to exaggerated heights." People often reduce it to Einstein was a patent clerk before becoming a physicist, as a way to show that even people in redundant jobs can achieve greatness, but that avoids diagnosing the mechanism beneath. The work didn't sit below him, it structured him, it became part of him. The environment and E had already begun compounding together, and nobody was watching. Einstein wasn't sitting in peaceful, scholarly isolation, thoughts drifting freely toward relativity. Peter Galison, Harvard historian and physicist, argues in Einstein's Clocks, Poincaré's Maps, Norton 2004, that the Patent Office wasn't incidental to special relativity, it was generative. Einstein was reviewing electromechanical timekeeping patents in a city where time coordination was made visible on every street corner. Bern, famed for its clocks, the same class of a problem that would become the conceptual core of special relativity. The thought experiments he used to develop relativity mirrored the exact engineering problems arriving at his desk every morning. Time synchronization, simultaneity. The Patent Office didn't keep him from his work, it handed him the raw material disguised as drudge work. Galison goes further. Einstein's early papers don't even read like scientific papers of his era. They read like patent specifications. The form of his thinking had been shaped by years of examining other people's inventions with ruthless skepticism. Einstein himself called the patent work a veritable blessing, saying it enforced many-sided thinking and also provided important stimuli to physical thought. We've been sold a false image. Einstein, the philosopher-scientist, head in the clouds, untouched by the mundane world. Einstein himself was complicit in building that myth later in life because it served him. The more accurate picture for this period is a patent officer-scientist someone engaging daily in a practical, skeptical, systematic way with the cutting edge of technology. The theorist needed the examiner the way the needle needs the magnetic field. The visible motion only makes sense because of the invisible structure beneath it. The theorist generates the hypothesis. The examiner provides the mechanism by which that hypothesis gets stress tested against reality. Einstein's patent office years gave him that examiner function built into his daily routine, which trained the same muscle he would apply to his own theoretical claims. Across 6 months, from March to September, 5 papers arrived, 4 at Eine der Physik and 1 at the University of Zurich, with no institutional affiliation attached, just a patent clerk sending documents that would soon restructure the foundation of physics. The first, submitted March 18th, claimed that light must sometimes behave like a stream of particles with discrete energies, quanta. The second paper offered an experimental test for the theory of heat and the proof of existence of atoms. The third, submitted June 30th, addressed a central puzzle for physicists of the day, the connection between electromagnetic theory and ordinary motion, and solved it using the principle of relativity. The fourth, submitted July to the University of Zurich, was his doctoral dissertation, a new determination of molecular dimensions. The work he had withdrawn in February 1902 under circumstances still debated by historians, now resubmitted and completed. The fifth, submitted September 27th, showed that mass and energy are two expressions of the same thing, that the energy contained within matter equals this mass multiplied by the speed of light squared, that mass is highly concentrated energy equals mc squared. Historians call it his annus mirabilis, his miracle year. But it was not a miracle. It was the inevitable output of a man who had been reviewing time synchronization patents in the city of clocks, thinking about invisible forces since a compass disturbed him at age 4, writing the foundations of relativity in a chafe house and boarding room above a restaurant while broke and stateless and in love with a woman 20 kilometers away he couldn't afford to visit. A man whose father had just died before seeing any of it arrive. A man the formal world had filed under clerk and moved on from. Nothing about this was sudden. This is incrementing E made manifest. Einstein left the patent office in 1909 for an academic appointment at the University of Zurich, made possible in no small part because Max Planck, one of the most respected physicists alive, had championed his work early. Without Planck's endorsement, an oddball outsider submitting papers with no affiliation might have been quietly ignored. Grossman opened the door to the patent office, Planck opened the door to the academy. A strong enough signal will attract receivers strong enough to amplify it. Einstein knew the work was not finished. In his own words, that the special theory of relativity is only the first step of a necessary development became completely clear to me only in my efforts to represent gravitation in the framework of this theory. 1915, General Relativity. Einstein extends his own framework to incorporate gravity, then published a paper the following year, his major 1916 review article, Die Grundlage der allgemeinen Relativity. I don't know why I try to pronounce that. The foundation of the general theory of relativity. Establishing the theory's comprehensive framework, laying out what that meant for the structure of the evolution of the universe itself. Introducing the cosmological constant, the first step in modern theoretical cosmology. Einstein had rewritten the rules twice in a decade. The compounding had not stopped. It never does. E is approximately 2.718, but forget the digits. What E represents is the rate at which things grow when they grow naturally, without interruption, without the theater of performance. Observation changes behavior. E doesn't give a damn who's watching. Every moment feeds the next, compounding on itself like an Ouroboros, just accumulation feeding itself in eternal recursion. The snake doesn't consume itself out of destruction, out of necessity, because the only available nourishment is what it has already become. Every previous version of itself becomes fuel for the next. Past doesn't disappear, it converts, it becomes the body that moves forward. That is E. Not a line, a spiral. Each revolution larger than the last, because it's built on the circumference of everything that came before it. It doesn't shrink, it expands through the very act of self-consumption. Silence on the outside, compounding on the inside, and to the uninitiated observer it looks like nothing is happening at all. That is what the patent office looked like from the outside. That is what your current season looks like from the outside. That is what every compounding environment looks like before the output arrives. So what does it look like when we actually map it? The Euler method gives us a window. We choose our resolution, the size of each step forward through time. Too large of a step and this trajectory diverges, splitting wildly away from truth into nearly impossible states that we often can't handle alone. Too small and we spend forever watching almost nothing change. The useful range typically sits between fine enough to trust and coarse enough to see. In many natural systems, change is proportional to what already exists. The Euler method offers a way to approximate these dynamics. Instead of solving an equation all at once, we move forward through time in small steps, repeatedly updating the system using its current rate of change. So, step by step, the future unfolds from the present. What looks like decay is often just a system doing exactly what the mathematics requires. Entropy increasing, energy dispersing, and this is how knowledge compounds. This is how craft compounds. And this is how signal amplifies. You don't feel it building, but the ceiling never stops rising. The patent office wasn't a detour in Einstein's story, it was the story. The compounding environment that made everything else possible. After 1905, Einstein spent the last 30 years of his life attempting to build the unified field theory, to unify gravity and electromagnetism into one framework which never converged. Simultaneously, he rejected quantum mechanics, famously declaring that God does not play dice, even as the rest of theoretical physics moved in that direction without him. The hours poured into work, the dedication never wavered, but the direction started diverging from where the consensus was going. E amplifies whatever you feed it. Consistency without direction compounds isolation just as effectively as it compounds mastery. Feed it wisely, because energy is never created or destroyed, only converted. Every hour Einstein spent thinking, reading, writing in that office, that was energy entering a system which converted into experiment, clarity, and theory, into 5 papers that restructured the foundation of physics as we knew it. Think about what happens to energy when it has nowhere to go. It compresses because it's never realized nor assimilated, so it turned inward, building pressure relentlessly, and when it finally releases, it's structural, reshaping whatever it touches. We've all seen it. Someone suppresses themselves until they can't anymore, then they erupt. And not with clarity, but with force, accumulated, unprocessed energy, looking for somewhere to land. At that point, it isn't emotion anymore. It's energy made tangible, converted into pressure, then released as impact. Your focused work is energy. It obeys the same law. It has to go somewhere. However, the question is never whether it compounds, it's whether you're feeding the system consistently enough and with enough intention for the conversion to even matter. What are you putting your energy into, and why would it be valuable enough to be preserved? By 1933, Einstein is the most recognizable scientist on Earth. He's visiting America when Hitler takes power. The Nazis raid his house and they burn his books in the street. He resigns membership in the Prussian Academy of Sciences, gives up his German citizenship while remaining a Swiss citizen, and does not return to Germany. Instead, from the US, Einstein goes to Belgium with Elsa and sets up temporary residence at Côte-sur-Mer. Later, his close family joins them and security guards are assigned to protect them. Einstein takes trips from here to Oxford in Switzerland, where he makes what will be his final visit to his son Edward. Rudolf Kaiser, Ilse's husband, manages to have Einstein's papers in Berlin sent to France and eventually brought to the United States. In September, he leaves Europe, arriving in the United States in October on the Westmoreland, while his stepdaughters and spouses remain in Europe. He needed somewhere to go. The Institute for Advanced Study in Princeton had been founded on a specific principle, That exceptional mind should be free to pursue knowledge for its own sake. No teaching, grants, no administrative obligations, no deadlines. That same year, Einstein publishes with Sigmund Freud a pamphlet called Why War and begins his professorship at the IAS, temporarily housed on Princeton's campus in Fine Hall. As World War II approached, the IAS worked specifically to extract brilliant Jewish academics from Europe, Einstein being among the first. He had been a pacifist his entire adult life. The cartoon shows him shedding those wings, dropping non-resistant pacifism and picking up the sword. People often do better when they're not perpetually threatened. He didn't go back, he couldn't. But the signal he had transmitted in silence, the work he had done in obscurity 2 decades earlier, had built the room that was already waiting for him. It was so strong an institution reorganized itself partly to preserve it. Compounding does not guarantee ease. It doesn't insulate you from the world's violence or indifference, but it does build signals strong enough that the world responds to you, even in crisis. Claude Shannon gave us the mathematics of communication. Every system has signal and noise. Noise is dissipating, scattered, inconsistent, and unfocused input. Signal is intentional, continuous, directed. It propagates upwards, it finds receivers. Einstein's receivers in 1933 were institutions, governments, scientists, people who had been tuned to his frequency for decades without ever meeting him. The signal travels ahead of you and prepares the groundwork. Jung said, "Do your work conscientiously and wholeheartedly, and unknown friends will find you." That is information theory. Clean signal travels, scattered noise cannot. Jung knew this, Shannon proved it mathematically. Every contemplative tradition in human history points towards it from a different angle. Unknown acquaintances are being routed toward the frequency you're building right now, whether you can see them or not. Every moment feeds the next, mechanically. What we experience doesn't disappear, nothing is lost. It gets processed, compressed, and folded back into us as structure, reflexes, thought patterns, bias, insight. Variables are adjustable, time scale, learning boosts, the rate of each injection, vitality responds accordingly. It rises with each feeding and decays without it, exponentially. No exceptions. But observe what does not collapse when vitality drops. The structure remains, connections persist, they have already been reinforced. Each input does not merely elevate, it hardens the system, increasing load-bearing capacity before decay initiates. Each connection is strengthened by prior input, building the capacity to survive longer between injections. Not merely gaining energy, but capacity built to endure its absence. Vitality is transient, resilience is retained. One fluctuates, the other compounds. There's one more detail. In 1926, 17 years after leaving the patent office, Einstein contributed to a patent on gyroscopic compasses and received significant royalties. The invisible force that had disturbed the 4-year-old boy in Munich, that had set the entire trajectory of his intellectual life in motion, he had become expert enough in its mechanics to patent it. The compass comes full circle. This is what compounding does when you aim it with intention and feed it with honesty. The only variables are what you feed it and where you aim it. We are not separate from this, we never were. Do your work conscientiously and wholeheartedly, and unknown friends will find you. E is already running in you. The only question is what you're building toward.